All right, let's dive right in. We're going to talk about a simple yet really profound idea that might just explain everything. And I mean everything, from why time only moves forward all the way to the mystery of dark energy. It's called the time force hypothesis. It seems like a pretty basic question, doesn't it? But this question right here, it gets to the very heart of one of the biggest, most stubborn mysteries in all of physics, the arrow of time. Why does it seem to fly in only one direction? You know, we have these two amazing pillars of modern physics: general relativity, which describes the universe on a massive scale, and quantum mechanics for the super, super tiny stuff. They are both unbelievably successful, but they share this fundamental and, to be honest, really weird paradox when it comes to time. And here's the contradiction, and it is a massive one. The fundamental laws of physics themselves, they don't really care about the direction of time. You can run the math forwards or backwards, it all works out just fine. And yet, every single thing we actually experience, everything, is irreversible. An egg breaks, it doesn't unbreak. The universe has a clear, one-way street from past to future. Okay, so this is where the time force hypothesis, or TFH, comes in and suggests a pretty radical shift in how we think. Instead of trying to explain this one-way flow of time as some kind of statistical accident, it puts it right at the very center of everything. The idea is that this arrow of time isn't something that just happens to emerge. No, it's actually baked right into the universe's source code. So take a look at this. This is a standard, kind of beautiful equation that describes how a wave moves. You know, like a ripple spreading out on a pond. It's perfectly symmetrical, perfectly balanced. It works just as well describing a ripple expanding outwards as it does describing one magically contracting back to a single point. There's no direction of time built into it at all. And now, look at this. This is the core idea of the entire hypothesis in a nutshell. Look really close. See that? There's just one new term added to the equation, that little alpha term. It acts like a tiny universal friction, or damping, on absolutely everything. It introduces a fundamental imperfection into the perfect flow of energy. So what this does is it completely reframes our picture of the cosmos. The universe isn't some perfect, frictionless machine. Instead, picture it as this continuous river of energy that's always losing a tiny bit of its edge, always trying to settle down and find balance. And from this one, simple, imperfect process, everything we see, might just emerge. So you're probably thinking, how on earth could one tiny little damping term be responsible for everything? It's a fair question. So let's see how this one simple rule could build up into the complex reality we see all around us. So in this new picture, particles, like electrons, they aren't fundamental little balls. Think of them more like stable whirlpools that form in this cosmic river of energy. And the forces between them? Well, those are just the ripples and the waves that these whirlpools send out. And gravity, the grand force that shapes the entire cosmos, that's just the large-scale overall drift of the whole river. Now we get to what is, I think, the most audacious and powerful claim of this entire hypothesis. It connects the tiniest quantum effects to the expansion of the whole universe with a single, elegant identity. Get ready for this. So, on one hand, you've got this microscopic damping constant. The theory calls it alpha zero. Just think of it as the fundamental rate of friction that's acting on every single particle, every wave, at the quantum level. It's the local reason time flows forward. Then, on the complete other end of the spectrum, we have a number from cosmology, the Hubble constant. This tells us how fast the entire universe is expanding. This number describes the most vast, large-scale behavior of the cosmos that we can possibly observe. And here's the punchline. The time force hypothesis proposes that these two numbers, which describe wildly different scales, the quantum and the cosmic, aren't just related. They are the exact same thing. Let that sink in. The tiny bit of friction that gives time its arrow is the very same process that's driving the expansion of the entire universe. So why is that such a big deal? Well, if this one identity holds true, it could potentially solve some of the biggest head-scratchers in physics all at once. Dark energy? That might just be the large-scale effect of this universal damping. And dark matter could be an effect of this same damping getting stronger or weaker depending on the local energy environment. We wouldn't need new particles or new forces, just one unifying principle. Okay, so this is a beautiful, very elegant idea. I think we can all agree on that. But a theory is only as good as its predictions, right? And the great thing about this hypothesis is that it isn't just philosophy. It makes concrete, falsifiable predictions that we can actually go out and test right now. For example, it predicts that the gravitational waves we see from merging black holes should fade away just a little bit faster than Einstein's theory expects. It also predicts a tiny, but maybe, just maybe, a measurable change in the cosmic expansion rate over time. And it even wades into the murky waters of particle physics with a very specific calculation. For instance, there's this famous unsolved puzzle in physics called the Yang-Mills mass gap problem. This theory offers a solution. It predicts that a hypothetical particle made purely of the strong nuclear force, they call it a glue ball, should have a very specific mass. And that prediction, about 1.63 giga-electron volts, lines up remarkably well with the best estimates we already have from massive supercomputer simulations. That's a huge check in its favor. So what's the big takeaway here? What does all this mean? Well, this hypothesis is really asking us to reconsider our most basic intuition about the universe. What if reality isn't a collection of tiny, static parts that operate by perfectly reversible laws? What if it's something more fluid, more dynamic, more like a flow? The author of the paper that proposes all this sums up the entire idea with this simple but really powerful statement. It just perfectly captures the essence of the theory, that from a single, universal imperfection, this constant, irreversible flow towards balance, the entire complex, living cosmos emerges. And that leaves us with one final, pretty provocative thought. Could it be that the entire grand, complex story of our universe, with its galaxies, its stars, and with us, is ultimately just the result of the simplest drive you can possibly imagine, just energy seeking equilibrium? Perhaps the universe's most profound truth is just a flow finding its way home.